Okay, we are in 5-6, compare unit ratios for Envision Mathematics 2.0. Let's look at number 3. A car travels 115 miles and car B travels. How can you find which car gets better gas mileage? You really have two choices here, and I will solve it two ways. As we know, when we're comparing, we're going to need two ratio tables. So I'm going to do miles and gallons for car A. 115 miles, 5 gallons. Car B, miles and gallons. Now, we're thinking about those compatible numbers, 126 and 6. So when we talk about gas mileage, it's how far you can go on one tank of gas. You could find one tank, which is the point of unit rates, but personally speaking, I know that 5 and 6 are both compatible with 30. Now that's gonna be simpler for my brain. I'm gonna take my calculator out. 5 times 6 is 30, so 115 times 6. 690. 6 times 30 is 5. 126 times 5. 630. So for an equal amount of gas, this one can go farther. Therefore, car A gets better mileage. Because it goes farther with same amount of gas. Now, my work backs up my sentence. Car A gets better gas mileage because it goes farther with same amount of gas. Now, the point of this unit is to talk about rates, unit rates, which is out of 1. So I think what the question really wanted you to do is put a 1 there. Is it okay to solve it with equal amounts of gallons being 30? Absolutely. It's also okay to solve it with 1. So we're going from 5 to 1, which means we're dividing by 5. 115 divided by 5 is 23 gallons to the mile. 23 miles to the 1 gallon. Whew! It's been a long day. And here we're dividing by 6. So it's 126 divided by 6, which is 21 miles to the gallon. Again, proving that car A goes farther. Now there is another unit rate here. It's the third way you could solve it. You could see how many gallons it takes to go 1 mile. And this is kind of an inverse relationship, where here we wanted to go further for the same amount. Here we're going the same distance, so we want to use less gas. So I would expect this number to be less than this number. So here we're dividing by 115. Be a tiny number. 5 divided by 115, 0.043. ... Not a lot of gas required in order to go 1 mile. And down here, we're saying divide by 126. Divide by 126 is 0.047. So again, as predicted, car A uses less gas to go the same amount. So again, all 3 ways demonstrate that car A has better gas mileage. You only have to do it one way, but it's important to understand you have options. We completed number 4 in class together. We made 2 ratio tables, and I'm going to bring them over here. So we have the car and feet per second. 600 feet in 20 seconds. And we have the motorcycle, feet per second. 300 feet in 12 seconds. Now, personally, I see that I could change this to 600 to get an equal amount here. This is times 2, and this would be 24. So the car can go 600 feet in 20 seconds. The motorcycle goes 600 feet in 24 seconds. Therefore, the car is faster. Because it takes less time to travel equal amount, equal feet maybe, because I'm running out of space there. Now, if I was paying attention and reading the problem, I would have known I could have done that with unit rates and been done. So I may go back here and go, okay, well, here I compared feet to feet. Maybe I want to know how many feet it travels in 1 second. So that would be a unit rate. Here I'm dividing by 12 and dividing by 12. 300 divided by 12 is 25. Here I'm dividing by 20 and dividing by 20, which is 30. So the car goes 30 feet per second. The motorcycle goes 25 feet per second. Comparing, we've already said that the car is faster, so I'm just using an inequality there. Now, if you found the other rate, which I'll see if I can squeeze that one in here, which would be how many seconds does it take to go 1 feet, you're going to get a very, very ugly number because you're dividing by 600. And 20 divided by 600 is 0.03. Repeating. Here you're dividing by 300. 12 divided by 300 is, you could have done it either one of these rates and gotten the correct answer, because in this sense, it takes less time to go the same distance. It goes farther in the same amount of time. You just have to look at that relationship and make sure you describe it correctly. Now we're finding the unit price. So the unit price has to be one item. So we have tickets, we have dollars. So I want one ticket. So I have 7 movie tickets for $56. If I have one movie ticket, I'm dividing by 7. 56 divided by 7 is $8 for one ticket. We have ounces and dollars. 12 fluid ounces for $2.76. And I want the cost for one item. So I'm dividing by 12 and I'm dividing by 12. That I'm going to use my calculator for. 276 divided by 12, 23 cents per ounce of shampoo. So it's going to cost me 23 cents per ounce. Next, better value. So I have books and dollars. 2 books for $15. And then I have books for dollars. 6 books for $45. Well, I guess I'm going to get an equal number of books by multiplying by 3 and multiplying by 3. 15 times 3 is 45. Ooh, look at that. Which is the better value? They're the same value. Same value. 6 books cost $45 for each. Now, I could have solved this by finding the unit price or the cost for one, but it didn't tell me I had to. So for me, I only had to adapt this one. If I did the unit price, I'd have to find the cost for one book and the cost for one book, which would also be equal. It's okay to solve it that way. I just chose to do it with an equal number of books. Let's go number to 8. We're only going to 11 here. 9 pens for $3.60. They're telling me to divide by 9. You can see 9 divided by 9 gives me 1. So $3.60 divided by 9 is 40 cents for 1. So 1 pen costs 40 cents, or 40 cents per pen. We're dividing by 15 to get to one item. which is ounces of canned beans. So I'm dividing by 15 here. $2.25 divided by 15. 15 cents. So it is 15 cents per ounce of beans. Last two. Now I am going to use my graphic organizer here for number 12 and 13. I might fold it over so it's a little simpler to see. But I know I need two tables for these, and it's just hard to kind of cram them in without my graphic organizer. So I'm going to call this A and this B. So for A, I have kilograms and I have dollars. So 3 kilograms is $7.95. And for B, I have kilograms and dollars. And it doesn't matter up here if it's dollars per kilogram or kilograms per dollars, but you always want to match your labels. So if you chose to do dollars in kilograms, you would just do dollars in kilograms for this one. You'd end up getting the exact same numbers. So we want to know which one's the better value. They're not forcing me to use the unit rate or the unit cost, but that might end up being easier. B is 5 kilograms for $12.50. I could find the cost for one. Personally speaking, I'd probably find the cost for 15 kilograms. I'll do it both ways, and the cost for one. So this would be the unit cost or unit price, the price for one item. So here I'm multiplying by 5, and here I'm multiplying by 5. $7.95 times 5 would give me $39.75 for 15 kilograms of charcoal. And then let's just find the unit cost while we're here. We're dividing by 3. So we're going to divide by 3. $2.65. Remember, the directions will sometimes force you to do that. So 1 kilogram costs $2.65. Let's go down and look at B. Here I'm going to be multiplying by 3. So I'm going to be comparing 15 kilograms to 15 kilograms. $12.50 times 3. $37.50. Remember, you need that zero there because it's money. So clearly B is cheaper. It's a better buy. Let's go through, and this should also prove that. Here I'm dividing by 5, and here I'm dividing by 5. $12.50 divided by 5 is $2.50 for 1. So here you can see that it's cheaper to buy 1, it's cheaper to buy 15. That ratio will always be the same. So when I go back and answer it, my sentence should be that brand B is the better buy because it costs less per kilogram, or equal amounts will cost less. If you found the other rate, which is a possibility, you could get the right answer, but you have to pay attention. So now you're finding how many kilograms you can purchase for $1. I'm going to come back here. I'm dividing by $12.50, and I'm dividing by $12.50. If this is the way you did it, that's fine. You get the right answer. This is 4/10. And here I'm dividing by $7.95. So I'm dividing 3 by $7.95. 0.377 ... So here I get more for $1. Here I get less for $1. Still means that this one's the better buy. Brand B is better value because equal amount costs less. And the last one is going to be 50 envelopes or 90 envelopes. Let's do that here on my graphic organizer. I'm going to call this brand A and this brand B. So we've got envelopes and we've got dollars. A, B, envelopes and dollars. 50 for $2.49, 90 for $5.50. Personally, I might go to 10. It seems like I could divide here by 5. $2.49 divided by 5. Let's go. 498 So cost 10 envelopes is just under 50 cents. And I'm dividing by 9, so I'm dividing by 9. So just over 61 cents. So brand A is clearly less money. The point of this unit is to really find that cost for one. So if I found the unit price or the unit cost, I'm dividing by 50. I'm dividing by 50. 49 divided by 50. So that's just under 5 cents for one envelope. I'm dividing by 90. I'm dividing by 90. And that's just over 6 cents. So brand A is clearly cheaper. Brand A, because equal amount costs less. This cannot be a final answer without this work somewhere. There you go. We'll do more tomorrow.